Right, good day to everyone. So today we are going to discuss finally the profitability analysis, okay? So I know you've already encountered profitability analysis in your engineering economy subject, and this is actually just a review, okay? This is all just a review of what you are going to do for your plant designs. All right? Okay. So these are the topics that we are going to discuss today. So um, we have the preliminaries, and then we will discuss cash flow diagrams, general expectations or assumptions during the life cycle of a process plant, the basis of profitability criteria, the non-discounted and discounted profitability criteria, and then the risk evaluations, particularly the sensitivity analysis and the Monte Carlo method. Okay, so when we get into profitability analysis, before going there, we need to have the following. So we have the process design, the output would be the process flow diagram, and then we have all the material and energy balances calculations. So you've already done that. That includes the production and including the in-process stream rates, the QFD, and the utilities table. So you all need that. And then after making the material and energy balances, you need to select the equipments, the design and the specification of each equipment to suit your process design and your material and energy balances. And then you need to cost the equipment, including the total capital investment, the total product cost, and the sales revenue. Okay, so you already have the cost. Next, after the costing, you will need to know if your process plant is profitable. Okay, so that's why you do the profitability analysis. After the profitability analysis, the designer or the one who designs the plant, the process plant, may possibly go back to step one to improve or optimize the process design. So anywhere in that process of making the process plant, anywhere in this process, you may think you are able to still improve or optimize, then you can go back to step one, okay? So this is actually an iteration. The making of a process plant is an iteration, okay? All right. Okay. Profitability analysis. So we've already tackled this. You've already tackled this in engineering economy. So profitability analysis requires prior knowledge of the following. So we have the engineering economy, including depreciation. We have equipment layout, sizing, and specification of all equipment and their costs, and the estimation of the fixed capital investment, working capital, the total capital investment, and the total product cost and the sales revenue. Okay, so in profitability analysis, you need all of these prior knowledge. So you can't do the profitability analysis without knowing the following. Okay, so the profitability analysis is based on the firm's cash flow. So as you can see at the diagram, so the cash flow includes the cash inflow, the cash in hand then increases, and the cash outflow. Okay, so normally a table, but it is best represented graphically. So it can be shown, it will be shown in a cash flow diagram. Okay, so the cash flow diagram visually represents income and expenses over some time interval. The diagram consists of a horizontal line with markers at a series of time intervals. So at appropriate times, expenses are costs are shown. So the cash flow diagrams are just visual representation of cash flow tables. So indicated cash flow could either be discrete or cumulative. Right? So this is an example of a cash flow diagram. So the one in black is the cash flow diagram. So as you can see here, it is done in years 0 to 12. Okay? And you can see the broken lines. So that is the cash flow. Okay? Or here, the cash outflow, the cash flow is cumulative. Okay, so this is not discrete, but this is cumulative. All right, so you may have seen a discrete cash flow, but here it will help you if you're going to use the cumulative cash flow. Okay, so as you can see here, there are a lot of components. So we have the land, the land that you're going to use for the process plant. You have the fixed capital investment and the working capital. Now, as you can see that the graph is going down, that is because there is no cash inflow yet. Okay, so puro pa cost. Okay, and then as you can see at years 2 and above, so as you can see, there's already a decrease in the cash outflow. That is because at year 2, okay, we start working, or the plant start up is at year 2. Okay, all right. As you can also see, the break-even point is at year 9, more than year 9. Okay, so for some chemical engineering plant design books, the break-even point is synonymous to the payback period. This is due to the alternative assumption that the total capital investment has to be recovered and not just the fixed capital investment. All right? Okay. So we will break that down individually. Okay, so what to expect? So what are the general assumptions here? So it is assumed that new land purchases required are done at the start of the project. So that is at the time 0. So after decision has been made to build a new chemical plant or expand an existing facility, the construction phase of the project starts. So depending on the size and the scope of the project, this construction may take anywhere from 6 months to 3 years to complete. So a typical value of 2 years for the time from project initiation to startup of the plant is usually assumed. So it is sometimes assumed, so usually 2 years ang construction sa plant. And after construction, plant start up na dayon. So that is the assumption. Okay? So you may follow that 2 years construction, and then immediately plant start up at year 2. So over the 2-year construction phase, there is a major capital outlay. So this represents the fixed capital expenditures for purchasing and installing the equipment and auxiliary facilities required to run the plant. So the distribution of this fixed capital investment is usually slightly larger toward the beginning of the construction. So notice the sharp slope of the cumulative cash flow curve in year 1. All right. So usually, there is a major capital outlay. So since at the start we will be spending on equipment, which is our investment in the plant. So um, we need to buy facilities to run the plant, and so at usually at year one, it is slightly larger compared to year two. All right. Okay. Then, as you can see, at the end of the second year, construction is already finished and the plant is started. So at this point, the additional expenditure for working capital required to float the first few months of operations is shown. So mga cost or purchases that needed to start the plant. So usually mga materials, the first materials that will be used. So those are part of the working capital. So this is a one-time expense at the startup of the plant and will be recovered at the end of the project. So after startup, the process begins to generate finished products for sale and the yearly cash flows become positive. So this is reflected in the positive slope of the cumulative cash flow diagram. Okay. So usually the revenue for the first year after startup is less than subsequent years due to teething problems in the plant. Okay, so teething problems meaning dili ta diretso mag 100% capacity. So sometimes when the startup, during the startup, okay, we already have produced products, but this is not still not at the 100% capacity. Why? Because the plant is still prone, or the process plant is still prone to mistakes during the process because of its bago pa siya. It's still new. It's still a baby of some sorts. So that is why it is not practiced, or it is not recommended that a process plant starts at 100%. So usually it starts at maybe 50%, and then it increases as the time or the year goes by. All right? Okay, so the cash flows for the early stages of operations are larger than those for the later years due to the effect of the depreciation allowance. So the time over which the depreciation is allowed depends on the tax regulations and the method of depreciation used. All right, so also at the start or the early years of the operation, there's no depreciation yet, right? So depreciation usually starts towards the late na, or when nadugay na ang plant. All right? So depends on what depreciation method you're going to use. Okay, so at the early stage, wala pa depreciation or the tax regulations. Okay. So as you can see in the diagram at the right, so we can see a steadily rising cumulative cash flow over the 10 operating years of the process. Okay, so in my example, it is 10 years, but it is recommended, okay, recommended na 9 to 10 years lang ang inyong project life. Okay, so at the end of the assumed project life, it is assumed that the plant is closed down and that all the equipment is sold for its salvage or scrap value. That the land is also sold, and that the working capital is recovered. So this additional cash flow received on closing down the plant is shown by the upward pointing vertical line in the last year. All right, so as you can see here in the diagram, it is at year 12. Okay, so as you can see, 12 years young project life. And so we assume here that at years 1 to 2, it is year 1 to 2 is construction phase, and then the plant operates at in 10 years. All right, so it is expected na you will need to have 9 to 10 years. Okay, so your break even should be between, or should be at least 3 to at least 3 years. All right, okay. So if you try to employ a project life of more than 10 years, then you will need to include, um, consider replacing the equipment, depreciation, and etc. etc. So that is why for our study, or for our plant design, we only include 9 to 10 years of project life. All right? Okay, so remember that in reality, the plant will most likely not be closed down. So we only assume that it will be in order to perform our economic analysis. All right? So what are the major considerations? So again, the project life. So it is required for evaluation of profitability of a project. So standardization of project life is needed when comparing different projects. So project lives of 10, 12, 15, 20 years are commonly used. But for our PDR, so I would suggest that you employ at 9 to 10 years. 9 to 10 years. All right? So that you will not think about replacing your equipment and adding another capital investment in your cash flow diagram. Okay? So it is best to consider the time value of money when evaluating profitability. So the time value of money, that includes your tax, depreciation, inflation. So that is included in the time value of money. Okay. So let's move on to the profitability criteria for project evaluation. So there are three bases for profitability evaluation. You have the time, the cash, and the interest rate. All right. So for the profitability criteria, so you have two types. You have the discounted and the non-discounted. So the discounted, it includes the time value of money, while the non-discounted methods do not take account of the time value of money. So it is not recommended for evaluating new and large projects. So large projects typically stretch to over 20 years of project life. So dili siya, it's not recommended that non-discounted criteria will be used. Traditionally, however, such methods have been and are still used to evaluate smaller projects such as process improvement schemes. All right? So if there's already an existing process plant and there is a process improvement, then usually a non-discounted criteria, profitability criteria, is used. Okay. So let's discuss first the non-discounted profitability criteria. So for the time criterion, so you have the payback period. So this is the time required after startup to recover the fixed capital investment for the project. So typically, a shorter payback period, the better. Alright? For the cash criterion, so we have the cumulative cash position, or the CCP. So worth of the project, this is the worth of the project at the end of its life. So most of the time, it is difficult to compare projects with dissimilar fixed capital investment. Hence, CCP may not be very useful. All right. But the CCP, so you can see the CCP when you go back to the cash flow diagram. The CCP is the value of money at the end of your project life. All right. So that already includes the salvage value. All right. Okay. We also have the cumulative cash ratio. Okay. So it is CCP normalized by the initial investment. So the CCR is typically the sum of all positive cash flows divided by the sum of all negative cash flows. So if the CCR is more than 1, it implies that the project is potentially profitable. Okay, so that means that there is more positive cash flow compared to the negative cash flow. Now, for the interest rate criterion, we have the rate of return on investment, or simply the return on investment, or the ROI. Okay, so the ROI is the average net profit, annual net profit divided by the fixed capital investment. Okay, so the higher value of your ROI, the better. Okay, so companies set their own minimum acceptable ROI. So this is the rate in which you have your fixed capital investment is returned. Okay, so if dako imong ROI, it means that you have a higher profit, a high profitability. Okay, so it means that dali ra nimo mabawi imong fixed capital investment. Okay, so this is the illustration, as you can see. So you have the cumulative cash flow ratio, cash ratio. Okay. So as you can see, the ROI is the slope of the line after the startup. Okay. All right. So this is the illustration of the non-discounted profitability criteria. So you have the payback period, and then the CCR and the CCP. So the CCP, as you can see, it is at the end of the project life. The rate of return on investment, as you can see, is the slope in which the line is already becoming positive. So there is a positive slope. Then that line there is your rate of return, and then you have the payback period, in which you have already nabawi na inyong fixed capital investment and the working capital. All right. Okay. So let's do an example. So if a new chemical plant is going to be built and will require the following investments. So you have the cost of land, the total fixed capital investment. So you have the fixed capital investment in year 1 and in year 2. And then the working capital. Okay. So in other books, usually the cost of land is assumed a component of the fixed capital investment. Okay, the sales revenues and the costs of manufacturing are given. So we have the yearly sales revenue. So this is the after startup. You have the cost of manufacturing including depreciation allowance. So apil lang depreciation ana. You have the taxation rates, the salvage value, and the use of depreciation using a 5-year MACRS. And then you assume the project life of 10 years. So you need to calculate each non-discounted profitability criteria given in this section. Okay. So the sales revenue is just products plus byproducts sold times the price. So for a more realistic analysis, you may assume a gradual increase of production. So usually from a low rate of 70% or maybe 50% up to a full rate of 100% within 3 to 5 years since the startup. So this will also have effects on the cost of manufacturing. Okay? So the cost of manufacturing is the total product cost. Okay, so if you construct the discrete and cumulative non-discounted cash flow for each year. So you have at the end of the table, you can see the cash flow and the cumulative cash flow. So the project life is 10 years plus the 2-year construction phase, that is 12 years in total. And then as you can see in the investments, you have the investment of 10 million. So that 10 million is the cost of land. Then you have the fixed capital investment in year 1 as 90 and the fixed capital investment at year 2 is 60. So you have the 90 and the 60. Plus the 30 na working capital. Okay? Okay. And then it would be best if you have this table in making your profitability analysis so that you won't di na mo maglibog, okay? So so unsa pa to, there you have a taxation rate of 45%. And your yearly sales is 75. Your depreciation, so you have the 5-year depreciation. So as you can see here, that is the 30, 48, 28. So that is the depreciation. All right. Then you have the fixed capital investment minus the depreciation here. And then you have the sales revenue. This one, the sales revenue. It is 75 per year, but at the end you have the salvage value of 10. So that's 85. You have the cost of manufacturing, which is 30. And then okay, you have the cash flows here. This is the discrete cash flow and this is the cumulative cash flow. Okay. All right. Now for the non-discounted criteria, the payback period is the time required after startup to recover the fixed capital investment for the project. So this is calculated based on the cumulative cash flow when it is now equal to the FCI. which is 150. So that was 9, how much was it? It was 90 plus 60. Okay? So that is the non-discounted criteria, the payback period, or the fixed capital investment. So you need to recover that. And the time needed to recover that is the payback period. Okay. So as you can see in the table, so you have the positive cash flows. But if you look at the cumulative cash flow, it is at year 6 that we reach 150, more than 150. So if you're going to plot that, so the trend is not exactly linear, but we can approximate that it would be linear from year 5 to year 6. So by linear interpolation of years along years 5 and 6, the cumulative cash flow of exactly 150 is at 5.85 years. But since, okay, so since payback period is reckoned startup year, we subtract 2. Kaya nag-construct pa man ta in the first 2 years. So the payback period is and 3.85 years. So you need, after startup, you need 3.85 years to recover your fixed capital investment. So the cumulative cash flow position, so this has been calculated as the ending cumulative cash flow value. So katong cash flow value at year 12 mo, to imo ang CCP. Okay? So that was at 170.5 million. But for the CCR, or the cumulative cash flow ratio, cash ratio, so you have the formula, which is the 1 plus cumulative cash flow position over land cost, the working capital, and the FCI. Okay? So that is 1.897. So if it's more than 1, it means that the process plant is profitable. And then you have your ROI. So the ROI is at 11.4%. So the slope of the line can also be obtained by taking the average annual taxed income. Okay? So that is your ROI. So this is what it looks like. So as you can see, the slope is 32.05 per year. Alright? And if you get the slope, if you want to get the ROI, so you have to get the slope, or the yearly increase, or yearly positive income over the fixed capital investment, or the total fixed capital investment. And then you have to do it in how many years. The project life is at 10 years. Alright? Okay, so that is your ROI. Now let's move on to the discounted profitability criteria. So again, discounted profitability criteria includes time value of money. That could mean interest rates, inflation rates. Alright? So for the time criterion, we also have the discounted payback period. So this is basically the payback period, but all cash flows discounted back to time 0, or the present value. So take note that this cash flow is future forward. So we are at year 0. Okay, so we are at year 0, and we're trying to look at the next 10 years, or the next years of the project life. Okay, so in the discounted payback period, you have to um, bring all the cash flows back to time zero. All right. The project with the shortest DPBP is the most desirable. Okay, so the shorter the payback period, the better. For the cash criterion, so we have the net present value. So the NPV, it is the cumulative discounted cash position at the end of the project life. So simply all cash flows are reckoned to the present and summed up. Okay, so if you have the cash flow diagram at year 12, you have to bring that back to year 0 or whatever your project life is. For example, your project life is 10 years plus 2 years construction phase. Then at year 12, so that is when your project ends, you have to bring that back, the value of that position, the value of that year to the present. So it's like the CCP or the cumulative cash position, and you have to bring that back to the present value or the year 0. So it is also normalized to be able to compare several projects. Okay, so if you have to choose between projects in which you have different project lives, then it is better to use this discounted profitability criteria because it is normalized to the present value. Okay. We also have the present value ratio, or this is the present value of all positive cash flows over the present value of all negative cash flows. So it's still like the CCR, but you have to bring all of the cash flows back to year 0. So if the PVR is more than 1, then it implies that the project is potentially profitable. For the interest rate criterion, so we have what we call the discounted cash flow rate of return. So the interest rate at which all the cash flows must be discounted in order for the NPV of the project to be equal to 0. So it's still like the rate of return, but then you have to bring all of that to the net present value. So it represents the highest after-tax interest or discount rate at which the project can just break even. So this internal interest rate is usually determined by corporate management and represents the minimum acceptable rate of return that the company will accept for any new investment. So if the DCFROR is greater than internal discount rate, then the project is considered to be profitable. So DCFROR tells us how efficiently we are using our money. So the higher the DCFROR, the more attractive the individual investment. So example, so we still use the previous na example, but we get the discounted payback period, the net present value, and the present value ratio. So assume a discount rate of 0.1 or 10% per annum. Okay, so that could mean the inflation rate or whatever discount rate that affects time value of money. Okay, so you have the non-discounted cash flows here, as you can see, non-discounted. So if you do a discounted cash flow, so for net present value, so you have this. Okay, so you have this formula. Okay, the formula, the present value from the future value. So you have F over 1 plus R to the power of N. Okay. And then you now have your cumulative discounted cash flows. Now, for the payback period, discounted payback period, you have the years at between 7 and 8. So by interpolation, the estimated year is 7.91 years. So we subtract 2 years, and so the discounted payback period is at 5.91 years. Right? So we calculate based on the discounted cash flow, cumulative cash flow. Then the net present value, so you just check the last year. So this is the this is the CCP, but discounted. So as you can see here, it is 17.12. So that is the net present value. And then you have the PVR. So the PVR is calculated at 1.1. So it means that is potentially profitable. Okay? So this is what it looks like. So the discounted and the non-discounted criterion, so it is actually the same. But it would be best if we account for the discounted cash flows, especially if your project is long, all right, or large projects. But since we are considering 10 years of project life, or 8 to 10 years of project life, we still need to get the discounted cash flow. Alright? So need gyapon of discounted cash flow and discounted criterion. Right? Now to get the DCF ROR, so you have the NPV of the example. Okay? So you have the interest or the discount rate and the NPV. So the value of DCF ROR is found at NPV equals 0. So interpolating from table E8.3, so our DCF ROR is 12.1%. An alternate method for obtaining the DCF ROR is to solve for the value of I in an implicit nonlinear algebraic expression. So, a better way to implement everything in Excel, where a cell containing the assumed discount rate is referred to by formulas for the discounted cash flow. So, you can use the goal seek or the solver to automatically calculate the DCF ROR with setting of NPV to 0. Okay? So, you can do all of this in Excel. You can use goal seek or solver. Okay, so let's make practical sense of these profitability criteria. So what is it for? So company management usually provides their own benchmarks or hurdle rates for acceptable profitability criteria that must be used in comparing alternatives. So common examples would be the company ROI that is substantially greater than the prevailing bank interest rate. So if they borrow from a bank which has an interest rate of this rate, if they have a greater ROI than that, then they might consider the project. So if the technology is new or basically uncertain, then the ROI benchmark is usually set at a much higher level. So since new man ang technology, then usually ang ROI for that is also set higher. Some companies employ payback period of 2 years max. However, uncertainties in business always complicate management decision making. So, businessmen, as a general rule, are conservative and would tend to minimize financial risks. Okay, so let's have a case analysis. So, a company vice president has been asked to recommend which of the following two alternatives to pursue. So, option one would be a new product to be produced that has never been made before on a large scale. So, the pilot plant runs have been made and the product sent to potential customers. So, many of the customers have expressed an interest in the product but need more material to evaluate it fully. So the calculated return on the investment for this plant is 33%. We also have a second option. So a second plant is to be built in another region of the country to meet increasing demand in the region. So the company has dominant market position for this product. Okay, so you have the dominant market position, huh? So the new facility would be similar to other plants. So it would involve more computer control and attention will be paid to meeting pending changes in environmental regulations. So the rate of return is calculated to be 12%. Okay, so which would the vice president choose? Option 1 or option 2? Okay. Now, the analysis of the VP. So items that favor option 1 if pursued, that would be high return on the investment and opens new product possibilities. But if we choose options 2, okay, so we already have the market position for option 2, so it is well established. The market for the new product has not been fully established. So the manufacturing costs are also well known in option 2, but is uncertain for the new process. Transportation costs will also be less than the current values due to the proximity of the plant, and the technology used in option 2 is mature and well known for the company. So for the new process, there is no guarantee that it will work. So unsa kaya ang pilion ni VP? So the VP said, we have little choice but to expand our established product line. So if we fail to build these new production facilities, our competitors are likely to build a new plant in the region to meet the increasing demand. They could undercut our regional prices, and this would put risk our market share and dominant market position in the region. Okay, so clearly, the high return on investment for option 1 was associated with a high risk. So high risk, see option 1. So this is usually the case. So there are often additional business reasons that must be considered prior to making the final decision. So the concern for lost market position is a serious one and weighs heavily in any decision. So if our company already is in a good market position and is already in a dominant market position, so not expanding our product line in other regions could potentially harm our already dominant or our market share market share. All right, so basically other companies would the other competitors might, okay, they might undercut our market position. All right, so they will be the ones to cater the demands in other regions if we do not expand. Okay, so the relatively low return on investment of 12% given in this example would probably not be very attractive had it not been for this concern. So it is the job of the company management to weigh all of these factors along with the rate of return in order to make the final decision. Okay, so it's still up to you. All right, if you are a plant designer, it is up to you. Okay? So you have to be able to convince your investors why you are choosing the option that you chose. Right? Okay. Now let's move on to part 2. So here we are going to tackle risk evaluation. So until now, it has been assumed that the financial analysis is essentially deterministic. So that is, all factors are known with absolute certainty. In fact, nearly all of these factors are subject to change. So throughout the life of a chemical plant, so it is uncertain and subject to estimation error. So the question then is not do these parameters change, but rather by how much do they change. So here in risk evaluation, so we are taking account the changes that might the parameters that might change. So for example, the cost of manufacturing might change over the years, or let's say the product cost or the sales revenue. We have the capital investment cost. So all of those things is not really certain. So since we're only making an estimation. So as you can see here, this is a table of variation of factors affecting profitability in a chemical process. So you have cost of fixed capital investment, construction time, the startup costs and time. You have the sales volume, price of product, etc., etc. You also have the interest rates, inflation rates, the raw material and availability and price. All of this affect the profitability analysis. So this table will be a good basis for assumptions pertaining to variances in cost parameters that you will need to accomplish the risk evaluation. Okay? So the most important variables in that table is the sales volume, with the price of product and raw material being close to second. Okay, so clearly if market forces were such that we were able to sell only 50% of the original estimated amount of product, then profitability would be affected greatly. So the problem is that projections of how the variables will vary over the life of the plant are difficult and sometimes impossible to estimate. Nevertheless, experienced cost estimators often have a feel for the variability of some of these parameters. So in addition, marketing and financial specialists within large companies have expertise in forecasting trends in product demand, product price, and raw material cost. Okay, so we're taking into account here the variations of these factors for the sales volume and the price of the product and raw material. Okay, so here we are going to quantify the risk. So it should be noted that quantification of risks in no way eliminates the uncertainty. Rather, by quantifying it, a better feel can be developed for how a project's profitability may vary. So therefore, more informed and rational decisions regarding whether to build a new plant can be made. However, the ultimate decision to invest in a chemical process always involves some element of risk. So to a great extent, the risk associated with the variability of a given parameter is dependent on the effect that a change in that parameter has on the profitability criterion of interest. So for the sake of this discussion, the NPV will be used as the measure of profitability. However, the measure could just as easily be the DCFROR, the DPBP, and any other profitability criterion. Okay, so there will be a variation of the factors, and that we will see what the effect on the criterion, the profitability criterion, namely the NPV, the DCFROR, the DPBP, etc. Okay? So, in quantifying the risk, so there are three methods. So, we are going to employ two, which is the sensitivity analysis and the Monte Carlo method. Okay? So, let's look at sensitivity analysis. So, if it is assumed that the profitability criterion of interest, such as in this case NPV, is affected by parameters, then the first order sensitivity to parameter x1 is given in the mathematical terms by the following quantity. So in general, the sensitivity coefficient quantity is too complicated to obtain via analytical differentiation. Hence, it is obtained by changing the parameter by a small amount and observing the subsequent change in the NPV. So, you are going to change the parameters and then observe the change in the NPV. So for small changes in the parameters, it may be assumed that the sensitivities are constant and can be added. Therefore, the change in NPV can be predicted for a set of changes in the parameters using the formula. So you have this formula. Okay? So let's look at an example. So for the chemical process considered in the example earlier, so we can calculate the sensitivity of the revenue, the cost of manufacturing, and the fixed capital investment, and plot these sensitivities with respect to the NPV. So we consider the effect of a change of a 1% change. Okay? 1/2 on either side of the base case in each parameter on the NPV. Okay? So, as you can see here for revenue, we have a value of plus 1/2%. So, that is 18.17. And if we have negative 1/2%, the NPV is 16. So, we have the SI of 2.8. Alright? Or the S1 of 2.8. We also have the cost of manufacturing. Your SI is negative 2.8. And then for the fixed capital investment, your SI is at negative 0.88 per 88 year. Alright? So as you can see, this is the effect of the NPV. Now, if you plot that in percent change in parameter versus the NPV, okay? So, yes, so the sensitivity curves for parameters considered in example 8.15. Okay, so as shown, we can assume linear changes in the parameters if the change is sufficiently small. So that is at negative 0.6% to 0.6%. Okay? Or 1/2% of each side. So we have negative 1/2 and the positive 1/2 change in the FCI, cost of manufacturing, and the revenue, and their corresponding net present value. Okay? So this is your sensitivity curves. So what is the change in the NPV? Another example, what is the change in the NPV for a 2% increase in revenue coupled with a 3% in FCL? Okay? So you already have the formula earlier. And the change of NPV is at 0.24 million. Okay? So that is for sensitivity analysis. All right? So in sensitivity analysis, you are um, taking into account how sensitive your um, revenue, your factors to the net present value. Alright? So usually if gamay lang kaayo nga change in parameter, then you will be able to see how sensitive the net present value is. Okay? Now, let's discuss a little bit on scenario analysis. So, scenario analysis, returning to example 8.1. So, regarding the profitability analysis for a new chemical plant, assume that as the result of previous experience with similar chemicals and some forecasting of supply and demand for this new product, it is believed that the product price may vary in the range of negative 20% to 5%. The capital investment may vary between negative 20% to 30%, and the cost of manufacturing may vary in the range of negative 10% to 10%. So, how can these uncertainties be quantified? All right. Now, in scenario analysis, we have the worst case and the best case. So, the worst case is katong negative revenue and the positive cost of manufacturing and the positive capital investment. So what is the worst case? So you have the worst case and the best case. So next, these values are substituted into a spreadsheet and all the cash flows are discounted back to the start of the project to estimate the NPV. The results of these calculations are shown. So as you can see here, we have the worst case. So if we follow all the worst case for all the factors, so the net present value is at negative 59. Okay? We have the base case. So this is at our present. Okay? So unsa atong that is at 0% change. And then we have the best case. The net present value is 53. Okay, so from this result, the decision on whether to go ahead and build the plant is still not obvious. So, on one hand, the process could be highly profitable, but on the other hand, we could lose we could lose nearly 73 million over the course of the 10-year plant life. Okay, very conservative management may tend to decide against this project proposal since there is significantly high loss with the worst case scenario. So it would be nice if at the worst case scenario, our net present value would be positive. But then since this is negative, then it might be for conservative management, they might rule against this project. All right. So this is the scenario analysis. Okay, so in scenario analysis, it is quite weak in the sense that without any additional treatment, there is no measure of certainty that could be associated with the generated scenarios. However, it provides a prelude to a better method of analysis. So one can generate countless random scenarios and some probabilities could be assigned to each of these, and we can possibly quantify the cumulative probability of profitability or non-profitability. Okay? All right, so in the scenario analysis, so there is a mix. So you have the worst, base, and best case, and then all the others is it's a random scenario. Okay, random between the worst case and the best case. All right, so that is the scenario analysis. Next is we have the Monte Carlo method. So it is a probabilistic approach to quantifying risk. So these are the basic steps. So all parameters for which uncertainty is to be quantified are identified. So unsa nga parameters? You have the cost of manufacturing, you have the revenue, and the fixed capital investment. So the probability distributions are assigned for all parameters in step 1. Okay, a random number is assigned for each parameter in step 1, and using the random number from step 3, the value of the parameter is assigned using the probability distribution from step 2 for that parameter. Once values have been assigned to all parameters, these values are used to calculate profitability by way of NPV, DCFROR, or DPBP of the project. So steps 3, 4, and 5 are repeated many times. So for example, 1,000 times. So usually mauna siya ang pinaka minimum. Then a histogram and a cumulative probability curve for the profitability criteria is calculated from step 6. Okay, so we will make the histogram, and then the results of step 7 are used to analyze the profitability of the project. So since the Monte Carlo method is based on the generation of random numbers, no two simulations will be exactly the same. Some small differences between simulation results are expected. So a little background or a little review on probability and distributions. So there are assumed distributions. Okay, so we have the uniform probability and the cumulative density distribution. Okay, we also have the triangular probability and the cumulative density, its cumulative density distribution. Okay, so here we are I think we're going to use the, what will be shown is the triangular cumulative probability. Okay. Okay, so let's revisit the example 8.1. So all the parameters for which uncertainty is to be quantified are identified. As in example, we will assume that historical data suggests that there is uncertainty in the predictions for revenue, cost of manufacturing, and fixed capital investment. So probability distributions are assigned for all parameters in step 1. All the uncertainties associated with these parameters are assumed to follow triangular distributions with the properties given in the table. Okay, this is the table. So a random number is assigned for each parameter in step 1. First random number between 0 and 1 are chosen for each variable. So the easiest way to generate random numbers is to use the rand function in the Microsoft Excel's program. Okay. So to illustrate how the random values for the parameters obtained, consider the calculation for the cost of manufacturing. So the random number chosen was 0.648498 for the cost of manufacturing. So this number, along with the values of A, 27, B, 30, and C, 33, are then substituted for the P sub X. Okay? Once values have been assigned to all parameters, these values are used to calculate the profitability or the NPV or other criterion of the project. So steps 3, 4, and 5 are repeated many times, usually at 1,000. For the sake of illustrations, step 3, 4, and 5 were repeated 20 times to yield 20 values of the NPV. So these results are summarized in the following table. So you have 20 runs, okay? So you have random numbers for revenue, random numbers for cost of manufacturing, and random numbers for FCI. So you have 3 randoms and then its corresponding NPV. All right. So a cumulative probability curve, or the OGIVE, is created for the values of the profitability criterion calculated from step 6. To do this, the data are ordered from the lowest to the highest, and the cumulative probability of the NPV being less than or equal to the value of the on the x-axis is plotted. So refer to the second to last slide for more info. So this is the second to the last slide. Okay. So the results of the step 7 are used to analyze the profitability of the project. So from the figure, it can be seen that there is about 38% chance that the project will not be profitable. Okay. The median NPV is about 5 million, and only about 21% of the values calculated above 17.12 million, which is the NPV calculated for the base case using the most likely values of the revenue, cost of manufacturing, and the fixed capital investment. Okay. So here, you can still use Excel. So have all your data in one column in Excel and copy paste value all the data in another column and sort from the lowest to highest. So you follow the following steps here, and then you will be able to make your OGIVE in Excel. Okay, so that is our last discussion. So it is recommended for your plant design report. So again, let me mention again that the project life should be between 8 to 10 years only. Okay? So that is for standardization sa tanan ninyo PDR. And then the profitability analysis section should have the following. So you have the introduction. So this should provide the motivation of the profitability analysis and overview of the profitability measures calculated and the basic assumptions made. So assumptions could be the buying of land of year 0, a 2-year construction period, stage cash flow for FCI, and the project years, project life, and the depreciation system, and etc. And then you should present non-discounted, then discounted profitability calculations. And then all of the calculations or the criteria should have an explanation. Okay, so what does the criterion mean? So what does the results mean? Okay. And then for risk evaluation, you have to do the sensitivity analysis and the Monte Carlo method. And then also provide a detailed explanation. Okay? And then you have the summary for all of the presented criterion and the risk evaluation and the discussion. So summarize the results in a table followed by a detailed discussion on the significance of the results. All right? Okay. So that would be all for our discussion on profitability analysis. Please take note of the deadline for our profitability analysis section, and please keep posted. Thank you.